Good afternoon, everybody, and thank you for joining me today. Sorry for the late start, but we have got a few late arrivals, so just bear with me. So my name is Daniel Marsh. I'm the Business Development Manager here at Zeiss UK, and we're going to be going over the Wi-Fi 6 today and what it can do for resellers. So there is some quite interesting points in regards to the actual products that we've got, as well as the technology as well. So we're going to go through with a few facts as well. So obviously, as we know, as technology increases, the communication behind it also needs to increase because, like the people transmitting data, watching videos and things like that, the bandwidth reliance is becoming more and more. So with this in mind, obviously the next generation of wireless, which is the Wi-Fi 6, or also known as the AX range, has been introduced. Now, at the moment, the average person checks the phone around 85 times a day. That equates to around 5 hours a day. I mean, I know how many times I check my phone for emails and sometimes just to get rid of the notifications on there. So it is quite realistic that people do use their phones an awful lot and require the backbone networks to sort of be increased as we move forward. So what they anticipate is that in 2020, about 7 billion businesses are going to be connected to the internet, and about 20 billion devices are going to be connected to the internet as well. So as you can see, that's some really healthy numbers. So what we need to look at obviously doing is having a look at the next generation of technology and starting to implement that to anticipate further growth. And this can be in any sort of vertical, so whether it be in hospitals, retail, hospitalities, restaurants and cafes, it is used worldwide. I mean, I even know quite a few construction companies that use quite a few of our sort of LTE devices and external access points just to be able to offer connections to sort of new builds where they haven't got any fixed broadband lines as well. So let's sort of go into the information here. I am just going to do a summary of it. I'm not going to dig too much into the technology itself. But some of the benefits that Wi-Fi 6 gives you over the traditional sort of AC standard and the N standard is that you're going to be able to offer much greater speeds. So the Wi-Fi 6 can offer a theoretical top speed of 9.6 gigabits per second. It is about 4 times more capacity than the previous standards as well. And like the AC standard, it does operate in both 2.4 gigahertz and 5 gigahertz as well. So some of the things which have sort of improved over time, which are shown on the screen at the moment. So we're being able to offer sort of 8x8 radios with MIMO. Now this works on both the download and the upload as well, where it hasn't on previous standards. And I've got a comparison matrix as well to show you of the increases between the different standards. So the OFDMA, this is something that is traditionally used in sort of cellular networks, and it's a way of being able to break up the channel and allow users to get information much quicker. And I've got quite a good diagram that will sort of put that into perspective. So resource unit scheduling, so every data which gets transmitted from a client device to an access point has a form of scheduling to be able to get the information, so everybody gets the information they have requested. So that's sort of been enhanced as well. The modulation, that's increased to 1024 QAM. Now, what that basically means is that the amount of throughput you can get between a wireless device and a wireless access point has been increased. So that's why you're being able to get the higher speeds of like 9.6 gigabits per second. The BSS color, so this is a way of sort of providing like a color code to a specific access point, and what this helps do is reduce interference, especially when you've got multiple access points that you use to roam around. Sometimes it can actually cause interference with itself. So if you deploy a network with a lot of access points, it can cause its own interference. So the BSS color allows to be able to sort of mitigate this as such. And the target wake up time is a way of being able to offer power saving management for the client devices. So they only actually wake up and connect to the network and transmit the data as and when they need to. So it actually improves the battery life of the client's devices. And as we know, with certain phones, the longer you've had it, the batteries become really drained quite easily. So being able to offer this sort of level is obviously greatly beneficial to the clients. So some of the world improvements, as I say, a little bit of a matrix to show you the difference between what's classified as Wi-Fi 4, which is the N standard, Wi-Fi 5, which is the AC Wave 2, which we're all familiar with at the moment, and then the new Wi-Fi 6, which is the new AX standard. So as you can see, the maximum theoretical speed has increased from sort of 600 meg, then to 6.9 gigabits per second, and then it's 9.6. So as you can see, as we're moving through the standards, it is becoming much better in terms of the amount of throughput that you get on it. And then you can obviously see that obviously it is an improvement as you step through it. The sort of tech improvements, which I'm not going to spend too much time on. I mean, you will get a copy of these slides anyway. But you can see based on the release dates, the bands that have sort of been introduced as well, and the sort of the improvements as you sort of go through it. So you can see like the highest modulation for Wi-Fi 4 with 64 QAM, which has now been increased in Wi-Fi 6 to 1024 QAM, which again is to increase the amount of throughput that you can do. So one thing that I do want to sort of highlight is one of the biggest benefits I find in Wi-Fi 6. So traditionally speaking, with the legacy standards, A, N, and AC, they used a form called Ofdm, which is basically a time slot. So each color represents a user in the transmission of data, and they get put into a schedule, and then they get the information, then it moves on to the next person, and the next person. And as you can imagine, if one person's transmitting a lot of data, that could also affect the next person. And in essence, it just builds up like a queue, like what you would see in a theme park, where you're waiting quite a long time to be able to get your turn. What the OFDMA does is it allows you to actually split up that specific timing slot. So you'll see here that we've got like the red user, he's allocated a full slot, but then on the next time, it's actually been able to serve multiple users at the same time. So again, if I go back to the theme park analogy, this is in essence being able to get yourself a fast pass. So being able to jump the queue and get yourself in much sooner to get some of your data. So again, it's about improving the delivery of data to your devices. To put this in a visual representation that's easy to understand. So on the previous versions with the OFDM standard, if this spaceship was being carried down the road, everybody behind it will have to wait until either it's turned off or moved into a lay-by or whatever to be able to let the traffic pass, which obviously you're reliant on that particular user getting all its information. So if you start going to the AX standard, you'll see that it's much bigger in terms of how many people it can deal with at any one time. So obviously what you do need to be careful of, and I'll go into this when we start talking about the switching side of things, is you need to make sure your backbone network is capable. Because albeit on the right hand side where it's showing loads of cars funneling into a tunnel, if it starts squeezing it down, then it becomes congested, and then you'll end up with a massive traffic jam. So it's being able to maximize this as well. So the access points that we do currently have out now, so this month, all of our access points are now readily available, all of which are Nebula Flex enabled, so they can all be onboarded onto our Nebula platform. And you can see the sort of specifications as well as you work through it. Now, the one that I want to point out the most is the antenna. So you'll find that some of them are static, fixed, so they're sort of like ceiling mount specifically. Dual optimize, they allow you to mount them on both a ceiling and a wall, and I'll show you the reasons for that and the benefits of that. And then also our highest access point, which is the WAC 650S, has smart antenna, and I'm also going to go into details about that as well. If you pay attention to the LAN side of it, you'll also see that you start being able to introduce 2.5 gigabit Ethernet ports, and then when you get up to the WAC 650S, you've got the 5 gigabit. So again, the actual physical port on the back of the device have always been standard at a gig. Previous to that, it was 100 meg. So this is being able to offer 5 gigabit connection directly into the access point, which again, this is all about increasing your backbone to make sure you don't have any congestions, because you could have clients connected to this, and as soon as all the information starts going down into the port to get to the network, whether it be a server or whether it be the internet, if you hit 1 gigabit and you're trying to get more, then you're going to be restricted, you're going to be congested. So they've started implementing what's called multi-gig ports on the back of it. So let's sort of go into understanding what a dual optimized antenna is. So again, this is being able to basically flick a switch on the access point to optimize it for either ceiling or wall mounted. So what you've got with traditional access points, they are mainly installed on the ceiling, but you will find a lot of installations they install them on the wall due to cabling restrictions and things like that. Now this can actually cause some issues because if it's a fixed antenna like a lower range AX access point, then you'll see that the diagram on the right hand side shows you what happens between the different floors. So if it's 3 floors high and you've got an access point on each floor, then you'll start causing interference because of how the radio pattern is beamed out of the access point. Therefore, you're actually causing your own issues. So in this sort of deployment, then you want to look at going for the dual optimized antenna. And the reason for this is when you flick the switch to a wall, it physically changes the hardware radio pattern and sort of beams it out and squashes it. And it stops the interference between the different levels, but also increases your coverage on the level where the access point is. So again, that's a physical hardware feature within inside the access point. Some vendors might try and do it through software, but if you do it through software, then the actual power that the access point uses increases, so it becomes counterproductive. So as I say, it's a very good feature and really does help reduce a lot of interference. So this is one of my favorite sort of technologies that I've come across since I've been in this industry, which is called smart antenna. So smart antenna is really good for reducing interference and helping very high density networks. So the way it sort of works is if you've got a device which is causing some form of interference, so a microwave, for instance, runs on 2.4 gigahertz. So if you're running a microwave, you'll actually notice it'll trash your internet connection as well. So if you've got an access point that is near a microwave, as soon as the microwave is sort of activated, it then becomes troublesome for the actual connections and the devices that's connecting to it. Even if the devices are not there, because the access point is broadcasting and being able to pick up that interference, the modulation and the connection to all the clients is being affected, whether or not you're near it or not. And you might not even understand or know that it's happening until it becomes a sort of disaster. So what sort of smart antenna does is it will actually provide a distinct radio pattern out of 700 patterns, and it will actually help reduce and move the interference away. So what it does based on the interference and the environmental factors, what is the best optimized pattern for this particular device? It only takes about 100 milliseconds, which is a very small amount of time. And then once it's done that, it will actually help reduce the interference. As you can see on the diagram at the moment, it's actually focusing the beam towards a client and not broadcasting it towards the interference because it was causing issues. So as you can see, it's quite intelligent about how it works. It dynamically shapes different patterns in real time. So if the client is moving around and it detects another bit of interference, it will then provide it a new pattern from its 700 optimized patterns to be able to reduce that interference. So again, high density networks, potentially where you've got a lot of interference as well, it's definitely worth looking at a smart antenna. I mean, me and one of my colleagues have a bit of a joke saying if smart antenna won't fix your issue, then nothing will. And that is quite true. So again, if you're looking for high density networks where potentially interference is going to be a problem, definitely go for the smart antenna level access points. Now these are available in our AX range, but then we also do have some in the AC range as well. So you're not forced to go to AX if that's not what the client wants. So just bear that in mind. Because everything's increasing, the access point standards are increasing to offer higher throughput, then the switches need to do the same. If the switches aren't up to scratch, then there's no point in upgrading your access point. So bear that in mind. You need to look at the backbone network and the physical cable connections to make sure it is capable of delivering the level of connections you require. So let's just sort of go through the PoE side of things at the minute. So one thing that have been improved recently is adding what's called Ultra PoE or PoE++. So this is being able to offer 60 watt PoE budget. So this is for like the more heavy duty PoE devices. So for instance, our top of the range access point requires the BT standard because of the radios it uses, the technology that's within it. If you think CCTV, the cameras which have pan, tilt and zoom, so the sort of mechanical functions, they require the more advanced PoE wattage as well. So with the cables that you physically use at the moment, you've got Cat5e, Cat6, and Cat6a. And you'll see on the matrix at the top, obviously, we all know about the 100-meter limitations. But when it comes to Cat5e, if you're trying to push 10 gig down it, then it won't allow you. It'll only allow up to 5 gig at a maximum of 100 meters. Cat6, when it comes to 10 gig, can only do 55 meters, but Cat6a will allow you to do all of them. So my recommendation is, if you're doing any cable work, just to be able to future-proof it and offer the customer the potential to increase to a 10 gig backbone network, I would always look at installing Cat6a cabling. So the switches that we've got currently out, which are multi-gig, are our XS1930 series. So again, these come with multi-gig ports. The multi-gig ports can do over traditional Cat6 and Cat6a, 100 meg, 1 gig, 2.5 gig, 5 gig, and 10 gig on all of the ports. It's obviously got quite a nice look. I mean, the design that goes into our switch is now a much nicer, much visual representation than what they used to be. So it provides you sort of color LEDs to provide you a status update, what PoE is being delivered, what your PoE budgeting is, and also a locator as well in case you're physically trying to find it in a cabinet. There is also a restore button. Now this is really good because if you create what's called a last custom default config on it, basically if any changes are made and it stops the switch from working, you can press the restore button and that will actually roll it back basically to a last decent config that you saved that you know was working and you're confident in. So again, if you're not on site and you know full well you've got a decent config on there, you could tell the end user, go and press the restore button. I know I don't like people telling customers to press a reset button, but pressing the restore button is perfectly fine. Again, these switches, they support PoE++, so what's called Ultra PoE, and the standard for that is the 802.3 BT, and that provides 60 watt per port with a maximum budget of 375 watts. So as you can think, the switch is only quite small, so usually our smaller switches have a lower budget. It's more our 24 ports or our 48 ports that have a 375 watt budget. But because of the requirements for the access points, then the budget of 375 watts has been implemented into the XS1930-12 HP. So we've got a non-PoE version and a PoE version available. And on the PoE version, we've got 4 dedicated uplink ports. And on the non-PoE, we've got 2 dedicated uplink ports. So they're used for like fiber connections to other switches, to servers. Potentially, you could link aggregate them together as well, and increase the amount of capacity that can go through them and a bit of resilience. So let's understand a little bit of the competition when it comes to our switches. I'm not going to go into too much detail, but over here we've got a comparison matrix between Zeiss, Netgear, and D-Link. So you can obviously see straight away the highlighted parts are where obviously we stand aside from the competition. So introducing things like an additional port which can do full multi-gig. So as I say, 100 meg, 1 gig, 2.5 gig, and 5 gig, and 10 gig is the multi-gig standard. Whereas the Netgear and the D-Links can only do 1 gig or 10 gig, no in between. We obviously offer a couple of SFP plus ports on it. Because we support all the multi-links, we hit the standard of 802.3 BZ, which is being able to offer every single capacity over the multi-gig ports, i.e. the 1 gig, the 2.5 gig, the 5 gig, etc. One of the biggest things as well is that it's a layer 3 light switch, so adding a little bit of static routing in there to relieve the gateway of any potential congestion. And it's also hybrid, so it can be done in standalone and in cloud mode as well. So again, a full cloud offering across our AX portfolio for the multi-gig switches, which are required to power and provide the data for the access points, and the access points as well can all be managed within inside our Nebula platform. And yeah, as I say, you'll get a copy of all this, so you can review this once you get it as well. So for the 12 HP, as you can see, the distinct benefits are highlighted in terms of the port count. In terms of the throughput the switch can do as well is massive compared to like the Ubiquiti or the Netgear. And then like PoE budgeting indicator and things like that, just things that sort of help you out. And you'll see that ours is the only hybrid mode one, so ours can either be cloud or standalone, whereas Ubiquiti's is only cloud, Netgear's is only sort of standalone. So on the screen now, you will see that I've listed all the access points that are now available. You'll see that they can come in a single pack, a triple pack, and for the 510 and the 610, you can get 5 packs as well. When you do buy the multi-pack, and this is important to remember, if you buy the multi-packs, they do not come with a power adapter. And the reason behind that is because if you're buying more than one access point, you're rarely going to have a PoE switch powering them. We can obviously obtain power adapters for them. If you do buy a triple pack and you need a power adapter, we could obviously look at sourcing them from our sort of RMA center. But again, typically speaking, you're going to have a PoE switch in there. And then I've also listed the part codes there for the XS1930s as well. So the multi-gig switches, which are going to be used to power these access points. So pretty much they're coming hand in hand in terms of what you're looking for a Wi-Fi 6 installation. So that's really a quick overview as to our Wi-Fi 6 offering. So if you've got any questions, feel free to post them into the questions section, and I'll do my best to sort of answer them for you. So as I say, I'll give you a few minutes, and then I've got something I just want to discuss on the outside of Wi-Fi 6 as well. So it seems to be a bit quiet on the all questions, so I'll move on. But again, if you've got any questions, then feel free to post them in, and by all means, feel free to reach out to me on either LinkedIn or send me an email at daniel.marsh@zeissel.co.uk. So one of the biggest focuses for Zeissel UK this year is being able to offer our resellers to join us on a journey to become an MSP. So what is an MSP? An MSP is a managed service provider. And by 2025, the managed service market is set to increase to $356 billion, which obviously is a massive growth. So there's sort of an untapped market there that I think we can help all of our resellers get into. Now, there are some benefits that you can get. You can get a discount on licensing, up to 25% on Nebula licensing, up to 9% off SMB and cloud products. And then you also get priority access to our pre-sales and post-sales support that are based right here in the UK. So, for instance, I'm part of that team as well. So I would help in potentially having a look at your project, helping to pick the right products for it, and sort of guide you through the installation to make sure it's as painless as possible. And also as well, you do get free Nebula products with any live technical training which is attended. Obviously, due to the COVID-19 and things like that, on-site training and sort of office-based training at the moment is sort of on hold. But we are going to be looking at sort of running some virtual training in the future. It's just a case about getting people onboarded now and starting to make benefits of the discount opportunities. So you will see that you should have the ability to download a handout. So the MSP Zap advantages. If you download that, that will basically outline what I've just told you. But it will also provide you a link to both our partner portal and to our MSP registration form as well. So once you've filled that in, we get notified that you're interested. Then one of our team from the MSP campaign will give you a call. They will discuss your business, what we're looking to try to accomplish, and sort of guide you into potentially altering your business model into a more MSP environment where you can actually maximize the amount of margin you get. So it is going to be quite a good journey. We are offering free training vouchers on Nebula as well if you take part in one of our pre-recorded webinars and fill out a little survey. So it is an opportunity not only to provide you with that extra bit of knowledge of where we're looking to go in the future, but also being able to get yourself certified on the Nebula platform as well. That's pretty much me for today. So I thank you all for joining me. Obviously, it's Friday afternoon. I'm sure everybody's looking forward to the weekend. So I'll leave it at that. Again, feel free to contact me either by email or by LinkedIn. And yeah, I will help in any way I can. And hopefully you'll start looking at the Wi-Fi 6 products and seeing it as a really good fit for your clients. So thank you ever so much again for joining me. And I hope you have a good day and a good weekend. Thank you very much. Bye-bye.